Hello class, this is the last video in graphing the general shape of trigonometric values. In the previous two videos we saw how cosine was the function of taking an angle, putting it into a unit circle and measuring the length of x and mapping it along the y value of a Cartesian plane. And for sine x, it was taking degree angles or degree values of x, putting it into the unit circle and measuring the length of y at any angle and mapping it onto the Cartesian plane here. For our last function, tan, we need to use our identity that tan is equal to sine x over cosine x. And this one's a lot easier to consider, because if it's sine x over cosine x, the first thing we need to remember is that cosine cannot equal 0, because we cannot have anything divided by 0. At any point that we have division by 0, there is an asymptote at that point. So if you just take a look at our cosine, where they're equal to 0, at those points, there will be asymptotes. So at negative 90 degrees, there's an asymptote like so. At 90 degrees, there's also an asymptote, like so. And at 270 degrees, there is also an asymptote. Do it in purple. Where sine is equal 0, because it'll now be 0 over something. Take a look. When sine is 0, cosine is 1. So that will be 0 over 1. So 0 over 1 is 0. Also at 180 degrees, sine is 180. Sine of 180 is 0. Cosine of 180 is negative 1. That's 0 over negative 1. That's also 0. You can probably see that there's a pattern that will continue, that in between asymptotes, tan will intercept the x-axis, where sine is equal to 0. And now, what this will look like is as follows. Because we're doing sine over cos, if you take a look, between 0 degrees and 90 degrees, it'll be a positive number divided by a positive number. Hence why it'll always be positive for between 0 and 90 degrees. And what this will actually look like is, because cosine is getting closer and closer to 0, dividing by something really small means the number is getting exponentially large. So it's actually going to look like this. And on the opposite side, it's negative, and it'll look like that. And this strange pattern will actually repeat between every asymptote, like so. You'll see in a moment a neater version of these. Okay, so tan is this odd wave function that repeats with asymptotes. Now, of all these, the key points that we must take into account are as follows. The critical points and features of trig functions between the angles 0 degrees and 360 degrees are, here are the 4 ones. Intercepts, the x-intercepts, where these values peak, it's also known as the amplitude. The y-intercepts, we'll get into these later, that's the phase shift. And lastly, the period. We'll get into these in a later video. Where these functions intercept the x-intercept, Take a look. For sine, it's at 0, 180, 360. 0 at x equals 0, 180, and 360. For cosine is at 90 and 270. And for tan, it's just matching. It's just matching where the sine values are also 0. Peaks refer to the highest and lowest points of the curve. So if we go back to sine, the highest and lowest points of the curve are at x equals 90, that's the highest point. And the lowest point is x equals 270, that's for sine. But for cosine, it's at 0, that's the highest point, and 180, that's the lowest point. Oh, and also 360, forgot about that one. Remember, this is only accounting for between 0 and 360. Okay, we need to find more of these points if the domain is larger. Tan has no peaks, right? Because of this curve. There is no highest or lowest point. This arrow here indicates that it's going to continuously get larger and larger off to infinity. And this one here is going downwards off to negative infinity. As such, the range of the regular sine function is -1 and 1. Take a look. Because the lowest this function can ever go is -1, and its highest is also +1. Same goes for sine. The lowest here is -1, and its highest is +1. For tan, its range is -infinity and +infinity. And now lastly, here are the proper graphs of the sine function. This is what they should look like, very neatly done on the graphing calculator. As you can see, I did a okay job. But I hope that gave you an insight into the general shape and the idea of the sine function. Lastly, I've shown you all of these graphs in degrees, but you should be able to convert these to radians and the understandings will be the same. So I'll hope to see you in the next video where we get a bit further into these details here. Hope to see you then. Best of luck.